Hello, people! I'm Weird, and this is my video. Yesterday, there was an upload by one such Tekking101 about this beautiful gentleman here and his slow devil fruit powers. However, there was a question pondered. Why and how could this be possible? Physically speaking, that is. Well, good news. I happen to be a physicist. Indeed, I am a physics doctorate student just about to finish up my PhD in theoretical physics, and thus I stand to be able to answer these questions, however ridiculous they may be. Please, have a time with me. I'm spending all my free time on this. So, what is this power? What is happening? How can we measure this effect? And what other fun geometries can we notice about this power? All of these questions will be answered in this video. To start, what is this power? Well, as this is a response video, I would highly suggest going over to Tekking101's video on the topic. Indeed, I will tell you nothing. I am far too lazy. Please do go to his video. Links are in the description. Moving on, in order to answer the question of why and how this may be possible, first we must consider all that we already know about the devil fruit and its powers, all that has been already described to us by the most brilliant Foxy himself. The most obvious of these being the slow motion it causes. Any object caught in the slow motion beam is doomed to come to a crawl. Perhaps more interestingly, though, is the fact that it seems to slow gravity itself. While one may be able to slow through the forces of friction, ultimately, gravity is always active. To slow gravity itself is a different matter. Another important item that is mentioned by Foxy himself is the conservation of energy. Conservation of energy is a grand law of the universe. We must follow it as is described by the brilliant scientist himself. So, how do we follow these laws? How do we conserve energy while slowing down gravity and slowing our general motion as well? Perhaps I could tell you. We can alter the speed of light. Okay, time to get serious. In this section I will be going over some math and physics of relativistic time dilation on a body in motion. If this topic bores you at all, yes, you can feel free to skip, but I'd suggest not. I find it could be quite interesting. This is my life after all. Anyways, let's get into it. In the relativistic time dilation equation, we have two times, one on the left and one on the right, and with the one on the right having a factor in front of it. The one on the left, delta t prime, is said to be an observational time. This is the time observed by somebody not in motion. That is, be the one in motion looking at the object in motion. What do they observe of the time of that object? The object in motion, however, is on the right. The delta t describes the time that it perceives, that is the perceived time. This is multiplied by a factor gamma in front of it to relate the two. This gamma is known as the Lorentz factor. The Lorentz factor is related to velocity of the object in motion and the speed of light by this equation, 1 divided by the square root of 1 minus v divided by c squared. If you have any issues with this, you can always look up how to find this equation through geometry arguments and through describing the speed of light as being constant in all frames. However, as there are so many videos and so many articles on how to do this, and I am far too lazy, I will let you do that on your own. But I do suggest it is a fun exercise to do this on your own. Anyway, this is related to relativistic energies. As Einstein's famous equation goes, E equals mc squared, the gamma factor, the Lorentz factor, shows up here as well for an object in motion. So, in order to get the energy of an object in motion, all you have to do is multiply by this Lorentz factor, and we get the total energy that we shall use for our further calculations, E equals gamma mc squared. Now, working with a form of energy, we can discuss the relationship between the velocity of an object in motion and the speed of light, given the constraint of this conservation of energy law. Now, it will require a little bit of calculus to do this, but hopefully it should be rather understandable in a sense. So, what do I mean by differentiating the energy? Differentiating the energy is what will allow us to actually solve for this relationship. By taking the differential of the energy, which is the sum of the partial differentials, hopefully you understand that if you have calculus or not. Anyways, we're saying how do we difference energy? And since we're saying energy is going to be constant, we don't want energy to change by any means. So we're just going to set this equation to 0. This will allow us to separate out the two forms. So we have the partial with respect to velocity and the partial with respect to the speed of light to be described separately by this minus factor. And then we can bring over this dV by dC. This dV by dC will describe how fast this change will, the change in the speed of light will change the velocity of the object. As we are describing a change in the speed of light, hoping to change the velocity of an object. And that is given by this fraction over here of the partial differentials. The first differential that we'll look at is actually in the denominator. We will look at the delta E over delta V. So we start with that equation, plugging in our form for E, we see mc squared, and I've just taken some liberty to rewrite that gamma factor in terms of powers. Why I do this is that it makes it easier to see and understand the power rule for differentiation. So taking a partial differential with v, we have the speed of light going to be constant only for this version, only for this time. We will consider the speed of light constant when taking the partial with velocity of the object. Mass is also just constant always. And that will leave us with differentiating what is in the middle. By the power rule, we can bring down the minus 1/2 and then add or subtract 1 to that power. And that'll give us the 1 minus v squared c to the minus 2 to the power minus 3/2 power. And then this will be multiplied by the differential of that object in that 1 over square root. That is due to the chain rule. If you have a function of another function and you take the derivative, you derive the function of that inner function, and then you multiply it by the derivative of the inner function. Now the derivative of that inner function is in the same manner as described by the power rule. So we bring down that 2 from the v, and we put in, well, we can scrap out the 1 because it's a constant and it's going to its derivative is going to be 0. And then we also have constant minus 1 in front of the v squared and the constant c to minus 2 with it as well. So that's just going to bring down a minus, or it brings down to 2, but the minus is, it persists. So we get minus 2vc to minus 2 for that differential there. Then we can put it all together. We get this form. C squareds divide out, and we are left with mv times 1 minus v squared times c to the minus 2 all to the power minus 3/2. Moving on, we look to how energy changes with the speed of light. So once again, putting in the form, now we're going to have to consider what happens with c being changed and v being constant. Since this is the form of two functions multiplied together, we also have to do the product rule of two functions to take the derivative of the first, multiply it by the second, add it to the first, multiply it to the derivative of the second. Hopefully you understand that. Hopefully I got some calculus people here. Anyways, this can be parsed out as such. And then the equations are solved similarly using the product and chain rules. Product rule on the first brings a 2mc squared to 2mc, and the product rule on the second brings out a minus 1/2 times that value to the minus 3/2. And again, the chain rule, we take out that derivative of that inner part. And then the derivative of that inner part becomes, by the power rule, 2 times v squared c to the minus third, where it's minus 2. The minuses cancel out, and c to the minus 3 is c to the minus 2 minus 1, with velocity, again, being constant through all of this. We can write it in this form, and I just wrote it to make it more simple visually. We can see that there is going to be a common factor of 1 minus v squared c to the minus 2 and the square root. And so in order to combine these fractions, all we have to do is multiply the first portion by 1 minus v squared c to the minus 2. So we do that, and we can simplify it down by taking out an mc and then rewriting the denominator again in terms of the 1 minus v squared c to the minus 2 to the 3/2. And then this has common terms that again can be pulled out to look simpler. And we have this final form, mc times 2 minus 3v squared c to the minus 2 times 1 minus v squared c to the minus 2 to the minus 3/2. A little bit of a mouthful, but ultimately understandable. Going back to our form that we had for the differential of the energy that we wanted to be 0, we have our differential form in terms of velocity and the speed of light. We just plug in our values. So we recognize that that odd term, 1 minus v squared c to the minus 2 to the power minus 3/2, is the same on bottom and top, and the same with mass, and those cancel out to give us this simple form where we have minus c over v, 2 minus v squared c to the minus 2. We can multiply that c over v, or minus c over v, throughout, and we get the form 3 times v over c minus 2 times c over v. Now, this may look cool at first. It kind of is understandable, but it has contradicting behavior to what we desire. At a certain speed, if we set this to be 0, to make it so that there is 0 change when you change the speed of light, we have this set speed to where the slowness doesn't actually take effect. And we want it to take effect, right? It's an issue. Yeah, I mean, true enough that you have to reach this insane speed, but it's actually the fact that it's above this insane speed where the slowness effect actually takes effect. So when you're running slower than the speed of light, that's slower as most everything is, especially in One Piece. Yes, everybody is slower than the speed of light, except for the one guy who is literally light. Then everything else should move faster if you consider the energy to be conserved. This actually it only works for massless or for massive objects. For objects without mass, as light, like Kizaru, it still is slowed proportionately to the slowing of the speed of light because, of course, the speed of light is going slower. So it can't be faster. Anyways, all these contradictions tell us that total energy can't be conserved. We have to consider that energy has to be changed in some fashion. I think that this might be a mistranslation issue. Uh, Perhaps, you know, could be that it is some forms of the energy is conserved while maybe it's just kinetic is not. I don't know. It depends on the translation. I just think it's a translation issue here. Considering then that we are allowing energy to be changed, the discussion actually becomes a much simpler to just say that due to the speed of light decreasing, the speed of everything else decreases, as is just kind of something that happens with our universe. Um, I do not want to go into very specifics of that part, but anyways, now we can look to the real life examples of what happens with light and slowing down light. And this has to do with the index of refraction, as titled here. Again, light can be slowed in real life when we do observe it. It's actually everywhere when you think about it. This is related through the index of refraction by this form, where n is the index of refraction, c naught is the speed of light in vacuum, and c is the speed of light in a medium. This describes the whatever index of refraction, and you can see that if the speed of light is decreased, that the index of refraction is going to be greater than 1. And that is in fact what we will be working with. This happens in every medium, every medium. Air, even though it's close to vacuum, it too has a refraction index to it. It slows down light a little bit. Well, virtually at least. This is also more prominent in stuff like glass and water that we work with every day, where you can see something like a weird straw bending in a way that you don't expect it to. Or with glasses, being able to have a refracted lens that will give you better vision, or worse. Ah, I just please do read and watch other descriptions for how this works. I'm not going to get into that neither. This is already getting long enough. Now, with this idea of an index of refraction where we observe that the speed of light is lower, we can consider a mechanism that perhaps we can force this in. So, indeed, what we will be looking on is if we can force a change in n, we can subsequently force a change in the speed of light, which consequently, again, changes the speed of everything else. Um, Two more things, though, to consider about our slow fruit. We know it has a short-term instability. It only lasts for maybe 30 seconds. After those 30 seconds, everything seems to go back to normal. So whatever mechanism is holding this n in this place that is making the speed of light a lot slower and everything else slower, it is unstable in a fashion that will automatically fall back to normalcy after about 30 seconds. We also note that the direct beam is stronger. Anything that is caught in the beam itself seems to be going even slower than when the beam is released and the object is just free to fall slowly or move slowly, whatever matters to you. So we want to think about this. To visualize what I'm talking about with this forcing function and changing the index of refraction, let's go and put up a little graph here. And I'm going to hope in all heck that you understand. I do not expect you. This comes from an intuition and from background in physics. So please do not think about it too hard if you do not understand. If you do, that's fun. Then we can discuss. Anyways, so just going to draw in my graph here. We'll have an x and a y axis. On the x-axis, I'll have an n, the index of refraction, y-axis will just have some function of n, the forcing function, whatever. You can have a capital F for Foxy because he's a foxy man like that. This is going to be in the positive axis, so obviously with the increasing n, as discussed earlier, increasing index of refraction describes a decreasing speed of light. So as we move on to the right in this graph, that describes a slower speed of light. So here's the graph. It just kind of takes this shape. It has three separate points that I want to discuss. One is going to be at the bottom of this hill. This point is going to be the most stable. This is where, if you were to say take a ball and set it on a hill, this is where it's going to want to finally relax to. This is where everything is stable. This is the unit. Everything is stable right here. Then the second point is going to be right here, kind of in the middle. This is called a saddle point. Saddle points are known for being pseudo-stable. What that means is that things will stay stable until a certain condition is met. And you can think about it, again, like a ball. As if you set a ball on a saddle, it might stay there for a second, but if there's any little bit off to the side, it will ultimately fall off. So it has this NS for saddle point. And then we have at the end this very sharp point, this NU for unstable. This is just going to be where there's no hope for it staying at this point. You have to keep constant force on it in order to keep it at this point. You can, again, use the ball analogy, put it on a hill. What is it going to do? It's going to fall unless you catch it. So you have to constantly keep that ball there or else it's going to fall. And again, going from left to right, decreasing the speed of light, but increasing n, we have ns greater than 1 and then u greater than ns, describing these points. So in everyday life, we're going to be at 1. This is just going to be how the speed of light wants to act, how everything wants to act normally. But when Foxy activates his ability, this is going to have some sort of force to it that will force us to move up this graph. However, mechanism that is, it's not too far-fetched physically to speak in actual physics terms, but honestly, we do not know. And there's no way. This is a hypothesis. It's more than a theory. So that'll force us to go up the hill. However, once he turns off his ability, once that beam is turned off, then we're in a really unstable point. We're going to want to fall. So we go back down here to this point. Now this saddle point is somewhat stable, so it'll stay here for a little bit. But eventually that too will decay down and it'll fall after 30 seconds as described by the mechanism of the devil fruit. And so it falls back down to normal. So now everything is normal again. Again, once he hits us, we'll go up, deactivate, and fall down after 30 seconds. And everything returns to normal. Hopefully you could follow that. Again, this is just the machinations of a theoretical physicist. If that made sense to you or not, this is fun anyways. So I hope that you can at least understand that this makes sense to someone in the theoretical physics realm. For a little bit of fun, since we are considering a beam of rays that changes the n, the index of refraction, let's call them n rays. I gotta put in that joke. So that kind of answers the why this is possible. Now let's get into the how this beam can actually cause objects to be slow. For this, I'm going to put out the idea of a particle transfer. We know that, was discussed earlier, energy has to change. So I'm going to state here that something that makes sense to me, that the energy change is going to come from this information change, this slowness information. So we're going to say that what is emitted from Foxy using his power are these slow information carrying photons. And this is just going to be photons but they have this specific information about the edited index of refractions that this is going to be in the force function. If we just state that to be a fact, again, we have to accept this. This is magic in terms of anime. But, it could be physically possible, but there's no way to test it. Now, since these photons have the slowness information, they also must move at the reduced speed, since they cannot move faster than the speed of light, which they know to be a slower speed of light than what we observe. And this is actually seen in the anime, where you can see not an instantaneous beam of light coming out of nowhere, but a rather slow beam that you can kind of actually dodge rather easy, at least for superhuman, as you go in One Piece. Now, we also subscribe to the idea that these photons, though they carry the slow information, still act rather normally in the circumstance of interaction with matter. So when it comes to a matter interaction, it is absorbed into that object. And what's going to be different in this case, though, is that absorption actually transfers this slowness information into the object. Now, that object is imbued with the slow information, it is therefore slowed down. However, since that object just absorbed a normal photon, a normal light ray as it would know it, then it re-emits it as any other light was do in normal life. That's how reflections actually occur, how your clothes get your color. And we're just going to say that that light that is re-emitted has this pink-like hue. Now, one thing of note when Foxy releases his power is that there seems to be these light fringes around the beam, and it creates these white rings. And that actually follows really well with our idea of altering the actual time, the index of refraction, as you can consider if light hit the barrier, it would want to slow down and bunch up and then release, and that would give you this kind of brighter ring around the fringe, around the surface. However, it also exhibits an ideal of not being a constant emission. If this were a constant emission of these photons, we would see how the beam would be kind of all white, or we'd just see one giant cone as it spreads out in a cone-like fashion. But instead, what we see are these kind of bubbles that go along the way. That indicates that it's not a constant emission, but that these bubbles come off one at a time as Foxy would permit it. So how could we consider it affecting an entire body? If the light comes onto a surface and infects the surface of an object, how does that information transfer? So let's just kind of put up a diagram. So we're going to have our slow particle here, and we're going to have an object, and it's going to represent in layers. That slow photon is going to come in, and it's going to hit the surface of this object. The surface of that object is then going to absorb the photon and re-emit it, but in doing so, gets that slow information. Now that slow information is imbued on the surface of this object. However, since this object is in direct contact with the rest of its being, it can transfer one after another like a domino effect until it reaches the end. And so this information is transferred throughout the body. The mechanisms of that being the same kind of reason why your body even holds together. If you weren't one body, if you weren't able to transfer information across one body, then the body would just fall apart. And so, anyways, at the end of this body, if this light, if this incoming photon has enough energy, it can also kick off a little bit of that information. So he'll just push off a little bit more and let that photon again pass with more slow information to be passed on to another object. Now, that section of the how might have been a little bit quicker than the why, but hopefully that got around that you don't need as much of the how because it is a lot of visual cues that is given to you in the anime and I guess the manga itself too. Anyways, how can we actually analyze how slow or how fast is the slow? To do this, I use video analysis. As we know, there's two speeds. I decided to use two different scenes. And video analysis is just, I'm going to be taking the scenes, pulling them apart to actually see how fast things are moving. First scene I decided to analyze was when Robin was slowed down with the beam. And this would describe the really slow version where the beam is active. And this comes from the idea that the beam will be slowed down to its own speed of light. So we can actually measure directly the speed of light from this beam and thus the speed by which everything is reduced. That kind of friction. So we start off with this scene here. We see that Robin is being hit on her left shoulder with the beam, and then on another scene, on another frame, it is passed through onto the right side of her shoulder, and this whole takes about 0.2 seconds. To calculate the active beam speed, the speed of light of these beams, all we have to do is take apart the scene. So first we write down the speed equation, that is v equals delta d over delta t. That gives us the velocity equal to some distance traveled over some time. First, we need to know what that delta D is, so getting Robin's measurements for completely scientific purposes, and we find that or at least I found, that she is 0.31 meters between her left and her right shoulders, as that is how we decided to take the measurements for this value. So those two frames got us zero point 0.2 seconds. From that, we can just plug in, divide 0.31 over 0.2 to give us the speed of light. It'll be 1.5 meters per second. And this, if you divide by the known speed of light, it gives a value of approximately 5 times 10 to the minus 9 times the speed of light. That is insane. That is an insane multiplier. That's how much slower that slow beam makes you. Foxy's power is pretty powerful, and anybody who doesn't believe that is he doesn't understand. Now we also want to consider the unactive beam. For that, I will consider the scene where Foxy is showing off his powers to the Straw Hats, and he slows a cannonball. And this cannonball can be seen flying in a straight line in at least 2 frames, and between these 2 frames, it travels a nominal distance, and we can again actually measure that distance and that time. The time between those 2 frames is 2.3 seconds. So, wanting to make that a calculation, we first want to take the measurement of the cannonball. This is going to be approximate, all due to averages of the cannonballs and also the sizes of the characters. Just know I did a lot of video analysis to come up with this figure here. It's nothing that you need to be bothered about. So we have the width of the cannonball to be 0.15 meters. The portion of the width traveled during those 2 frames is about 0.2, about 1/5 of the portion of the width that it was able to travel. Again, that time from the video is delta t is 2.3 seconds. And then we also want to consider how it could be slowed from an average cannon fire. So we take an average cannonball speed. These speeds were really varied as I studied them, and also this is anime, it could be a different speed as well. This is a different world, it could be a different speed. Well, let's just say for the sake of the calculation that we know the average cannonball speed of One Piece anime cannonball to be 200 meters per second as fired by someone other than Garp. So we can plug this into our equation. So the slowed speed, v slow, is that multiplier, 0.2 by the width. So that'll be the total distance traveled, that multiplier by the width, and then divide by the change in time to give us 0.013 meters per second. And once again, dividing it by the average speed of the ball gives us the multiplying factor over here of 6.6 times 10 to the minus 5. That's going to be how much slower you end up being for 30 seconds. Again, the slow beam is rather powerful. Yeah, that is kind of cool. Now, another kind of question that I haven't seen pondered by anybody is about the hand signs and the specific way he shapes his hands. We know by other activated abilities like Bartolomeo's barrier fruit that the hand sign actually has some significance to it. Now, I don't think Foxy's is any different. Now, you can also chalk it up to coincidence that Oda was just kind of being artistic because it kind of looks like a fox. Anyways, if you actually look, if you were to do this hand sign yourself, let's just do it yourself for a second and just kind of look at it. You can see that there's this little bowl in here. And this bowl is actually kind of like a radar dish. This is like a dish that would be used for focusing a light ray. And that just makes sense. It actually makes sense. If you're dealing with light and if you want to make it into a focused beam, you would want it to be in a focused array. And the best way to do that is to use a focused parabola like beam fashion. It just makes sense, doesn't it? Uh, I just thought that was kind of cool to point out. This would, again, this allows you to actually make the directionality, because it could be possible otherwise for Foxy to actually activate without making this hand symbol, but by making his hand into this particular symbol is by that fashion of that geometry, focusing it into being able to make it into a ray instead of not just blasting it out radially as light would go radially like from the sun and affecting himself as well. Another inconsistency I can think of is, well, if this light beam affects everything, why does it not affect mirrors? Why does it just bounce off of mirrors? And for that, it does come to, again, you have to be a little bit fluid, a little bit elastic with your ideas of what this can all entail. So let's just say there's a caveat that the same mechanism that imbues the object with the slow information can also be transferred away by reflection. So as I stated earlier, the objects, when there is a reflection, objects actually absorb some of the light and then re-emit it. So let's just say in the caveat that for mirrors that are really shiny, not enough information can be passed on to them that they don't reflect off, and thus they reflect off and kind of brush away this end information. They just kind of shed it. So the mirrors aren't affected. Again, this is a little bit more of a stretch because this is anime logic. You just kind of have to go with it. So it's going to be a little bit different from the transmission through an object, but you gotta just kind of consider it in these anime logic fashions with this specific caveat. What I find to probably be the most unique form of this power is how Foxy has seemed to be able to fashion it into a sword-like weapon. Well, a blade, whatever you want to call this. Uh, and I think it actually kind of makes some physical sense. Again, it takes a little bit of anime magic and constructive ideals that you may not be completely familiar with, please understand that it does kind of make sense, at least to someone. These will be some words. Anyways, let's get on. We notice that it is an opaque sword, and this indicates that there's an increased intensity. Now, something fun that comes with light is that while it can move through what we see as room, like the air, if you can get an intense enough light, it will actually become opaque. Won't be able to see through it. It's really intense light, though, that causes this. But this is something that we see with Foxy. And now, something about this opaqueness of light is that it actually pulls in two things. One, it allows the mirror mechanism to create kind of like a laminar flow, because now it's going to be bouncing off of itself. Now it's an opaque, it's kind of like a fluid light rather than a gaseous light. Like the light is no longer free, it interacts with itself. And this allows it that if Foxy were clever enough or engineering enough, whatever, to make a mechanism in mirrors that could focus his beam in just the right way to make it like a laminar flow of light, and that he can actually cause it to reflect against its own space. That comes from the idea where if you have an area local that has a higher index of refraction and it's transferring to an area local of lower index of refraction, there is something called total internal reflection, where for a certain angle and below a certain angle, a light will actually completely reflect off the surface and not be transferred through. So that could possibly happen here. This could be this laminar flow space where just the sheer change in the index of refraction is causing it to bounce off of itself and to be in its self-contained in this fashion. Um, we also see when he attacks Luffy with it that it kind of lasts around his as like a bind. And this can kind of be an idea of the laminar flow of opaqueness of the light as well. That if the light gets trapped in there, if it's so intense that it gets trapped in there, that it can feed itself for a little while. It can be this kind of feedback loop of slowness, and it feeds on that self and retains it, making it a bind super tight for a long time. So I just think that's kind of cool. It's not necessarily as solid as the other ideas, but I think it's could be kind of shifted around logically to make that work, and I think it's cool. And yeah, that's all I got. Hopefully, this kind of helped out with a little bit of an understanding and tried to introduce some fun physics to you all to try to get it into your brains to try to think about how this world of magic and devil fruits could actually be kind of possibly, not really, but kind of explained physically in the real world. And I just think that's kind of cool. So, yeah, hopefully you enjoyed. I don't know why I did this.